Hello everyone. In today's video, we are going to discuss exactly how data travels through a network. Have you ever wondered what really happens after you type www.google.com into your browser and press enter? The web page appears almost instantly. But have you ever stopped to think about what actually happens behind the scenes? Does your computer send the web page request directly to Google? How does it know where Google is? How does your data travel across thousands of kilometers in just a few milliseconds? And how does the correct web page find its way back to your computer? In this video, we are going to follow the complete journey of a single request from your computer through your home network, across the internet, all the way to Google server and back again. By the end of this video, you'll know exactly how data travels through a network. Let's get started. Everything begins when you type www.google.com into your browser and press enter. Your browser is now ready to request Google's homepage. But there's one problem. Computers don't understand website names like google.com. They communicate using numbers called IP addresses. So before your request can travel anywhere, your computer must first discover Google's IP address. The first thing your browser does is check whether it already knows Google's IP address. It checks its own DNS cache. If the address isn't found, your operating system checks its cache. Your computer sends a DNS query to a DNS server. Think of DNS as the internet's phone book. You know the website's name. DNS tells your computer the IP address associated with that name. Within milliseconds, the DNS server responds with Google's IP address. Now your computer finally knows where Google is. But simply knowing the destination isn't it enough. Before sending any data, both computers must establish a reliable connection. Imagine calling someone on the phone. Before you start talking, both people first confirm that they are connected. TCP works in a very similar way. It establishes a reliable connection using the famous three-way handshake. First, your computer sends a SYN packet. This means I would like to communicate. Google replies with a SYN ACK packet. I received your request and I am ready. Finally, your computer sends an ACK packet. Perfect. Let's begin. Now, a reliable connection exists between both devices. Your browser creates an HTTP or HTTPS request asking for Google's homepage. Now it's time to send that request. Before the request leaves your computer, it must be prepared for its journey. TCP organizes the data and adds information such as port numbers so the correct application can receive it. IP adds two addresses, your computer's IP addresses as the source and Google's IP address as the destination. Inside your local network, devices communicate using MAC addresses, not IP addresses. So your computer needs the MAC address of your default gateway, usually your home router. If it doesn't already know it, it sends an ARP request asking who has the IP address of my default gateway. The router replies with its MAC address. Remember, ARP works only within your local network. It helps your computer reach the first router. Once the packet leaves your network, each router takes care of forwarding it to the next destination. Finally, Ethernet adds the source and destination MAC addresses, creating an Ethernet frame. The request is now ready to begin its journey. The Ethernet frame first arrives at your network switch. If you are using Wi-Fi, this role is usually handled by the switching hardware built into your wireless router. The switch checks the destination MAC address. It looks in its MAC address table to find the correct port. If it already knows where the destination device is located, it forwards the frame only through that specific port. This makes communication fast and efficient. The frame quickly reaches your router. Your router acts as the gateway between your home network and the internet. It removes the local Ethernet information, examines the destination IP address, and decides where the packet should go next. In most home networks, the router also performs network address translation or NAT. This replaces your private IP address with your public IP address before sending the packet onto the internet. The router forwards the packet to your internet service provider. From there, the packet travels through multiple routers. Each router examines the destination IP address, chooses the best next hop, and forwards the packet closer to Google's network. This process repeats in milliseconds until the packet reaches Google's data center. Google's network receives the packet and forwards it to the correct server. The server processes your HTTP request and prepares the web page. It gathers the HTML, CSS, JavaScript, images, and other files needed to build Google's homepage. Using the same TCP connection established earlier, Google sends the response back toward your computer. The response follows a similar path back. It travels through internet routers, your ISP, your home router, your local switch, and finally reaches your computer. TCP checks that every piece of data has arrived correctly and in the proper order. If anything is missing, TCP requests it again. Once everything is complete, your browser begins its work. It reads the HTML, applies the CSS, executes the JavaScript, loads the image, and renders the web page. Within milliseconds, Google's homepage appears on your screen. Let's quickly review the complete journey. You typed a website name. DNS translated it into an IP address. TCP established a reliable connection. Your browser created an HTTP request. ARP found the router's MAC address. Ethernet packaged the data into a frame. The switch forwarded the frame to the router. The router performed NAT and sent the packet to the internet. Multiple routers guided the packet to Google's server. Google processed the request and sent the response back. TCP ensured the data arrived correctly. Finally, your browser rendered the web page. Every website you visit, every video you stream, every email you send, and every online game you play follows this same fundamental process. Now you know what really happens behind the scenes every time you open a website.